As I just mentioned, coupling captures how strongly connected program elements are to one another. At the same time, not all kinds of coupling are equivalently problematic for software evolution. In this screencast, we will look at some concrete examples of coupling to help you reason about the coupling within your designs. Since these are small concrete examples, we'll be talking about coupling between classes and methods rather than components or modules. The way that we're going to reason about coupling is in terms of a flowchart. The first attribute we will consider is whether the coupling arises because of data stored and manipulated between different classes. Data coupling happens when classes share data through simple primitive parameters. In this example from the level class, we can see that the callers of set size are only sharing primitive width and height parameters. Since primitives are built into the language, the data types themselves do not impose more coupling on the system than the method call itself. Too many primitive parameters, though, can indicate poor data partitioning within the system, so just using primitives alone is not a panacea to avoid problematic coupling. Stamp coupling occurs when classes are coupled through data structures and well-defined public types. The example above is from Mario. Here we can see that any invoker of setState also needs to know about the size state enum. This works well when we have small, well-defined interfaces, but is more prone to maintenance work than data coupling because custom-defined types encode more constraints and are much more likely to change due to the diversity of fields that they contain. Control coupling arises when a caller controls the flow of computation within another unit. This is problematic because it means the caller needs to know something about the implementation of the callee that they probably shouldn't. In our example here from the keys class, what the status parameter does is not clear and could be improved by just having two handler methods that clarified what they were doing if the flag was true or false with much more descriptive names. And if you think about the implementation of the handler method itself, you can see the problem, because within handler there probably is an if block that checks the value of the status parameter and it executes one piece of functionality if the status is true and another piece if the status is false. And in this way, callers of the handler method need to know something about the implementation of that method that they really should be oblivious of. Now there is one more kind of data-oriented coupling that we skipped by earlier, and that's global coupling. And global variables are the root cause of this kind of coupling. Global variables make it much harder to reason about the flow of data throughout a program, and makes it easier to have subtle ordering bugs show up as the system evolves, because the global state might be changed in ways that were not expected. In this example from Gauge, $sign is itself a global variable. Here you could imagine computing this .view at the start of the program lifetime, but at some later time in the execution changing that view, but still having a stale this.view reference within Gauge that would probably cause some kind of problematic fault. The use of global variables also significantly impacts the reusability of code and decreases the testability of code. Finally, we have content coupling, which is the most problematic form of coupling. This occurs when the internal state of one unit is modified by another unit. The Mario system that we've been using doesn't have any examples of content coupling, but this is what one would look like. Here you could imagine that the Mario hit code could change the dead flag in an opponent directly instead of using a method. But you could see how this could be a problem if the enemy itself was a boss, or there's other reasons why that flag couldn't just be set to true. We want the types to be able to control their own internal state, so this type of content coupling can introduce all kinds of unexpected failures. Content coupling really results when there's a breakdown of information hiding and encapsulation, and represents the most fundamental violation of well-intentioned designs. It's important to remember that coupling is a natural part of software. To accomplish complex tasks, you will naturally have some complexity between the parts of your system. This is why coupling can be thought of along this kind of continuum. While you should absolutely avoid content and global coupling, being aware of the benefits and drawbacks of the other kinds of coupling will help lead you towards better designs. Ultimately, reasoning about how your code is coupled is important for increasing the long-term quality of your system, especially in terms of evolvability, reusability, and testability.